Hey everyone, welcome back to Code in Motion. Today we're looking at LeetCode problem number 424, longest repeating character replacement. So we're given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. So essentially what they're saying is we're given a string s, ab, with k equal 2. We could change any character inside of the string up until 2 times, and we could change that character to any other character we want. So in this case, we can replace 2 of these b's with a's. In this case, it's going to become A, and that length is 4, right? So replace the 2 A's with 2 B's, or vice versa, it doesn't matter. We're going to start the algorithm by initializing a couple of variables. First, I want to talk about the max length on top in blue. This is going to be our global result that we're going to keep track of as we iterate through the example. We also have a frequencies hash map on the right-hand side. This is going to keep track of each letter and the frequency of how many of each letter have we seen through a substring. We also have k is equal to 2 on the left side. This is just a reminder that in this example, we can change up to 2 letters to any other letters. We have the maximum frequency. This is going to tell us the maximum frequency of a specific letter in our substring. And then we have the current length of the substring that we're analyzing. We're going to be using a sliding window technique with 2 pointers, I and j. We're going to increment j as far as we can, and if we break our constraint of the problem, we're going to move the I pointer along. So after initializing all of this, we're going to scan the first index, which is a. We're going to increment the frequency of a in the hash map. Since it didn't exist before, that means it had a frequency of 0, and so now it's going to have a frequency of 1. Now we're going to update the max frequency to 1 and curlen to 1. The reason for this is because A has a frequency of 1, and that's the current max frequency in our substring, and the current length is now 1 as well. We're just seeing one character, which is A. Now we're going to check if the current length minus the max frequency is greater than K. This is really the most important condition of this entire algorithm. Cur length tells you the length of the substring that you're currently analyzing. Max frequency tells you what is the most frequent letter in my substring and what does that count. Now the difference between curlen minus the max frequency, it tells you how many distinct letters you have that are different from your most popular letter. And if that is greater than K, that means you can no longer flip all the letters to be the same exact letter. And so you'll need to move the I pointer. I know I'm saying a lot, but this is going to make more sense as we go on in the algorithm. So right now, curlen minus frequency is 1 minus 1, and 0 is not greater than 2, so we don't do anything with the I pointer. Let's update the maximum length to be the cur length, which is 1. Now we're going to move along to the second index, A. Now we increment A's frequency, so now it's 2. Now we update the max frequency and cur length to 2. And then we check if curlen minus max frequency is greater than K. In this case, it's not. My substring is a length of 2. My max frequency is 2. In this case, I have the same letter, AA. 0 is not greater than 2. And curlen minus the max frequency, it should start making more sense to you as we go through this algorithm because the cur length is 2, but I only have 2 A's. And so how many characters do I need to swap to A? Well, 0 characters because they're both A, right? So curlen minus max frequency, it measures how many characters you need to change to the most frequent character. Now in this case, we update max length to 2. And we move on to B. Let's update the frequency for B. In this case, it's just 1. This is the first time we're seeing a B. And let's update the max frequency to 2 and the curlen to 3. Max frequency is 2 because we only have 2 A's, right? The max frequency, it just gives you the value of the most frequent character, and we get that from the hash map. Now we check if curlen minus max frequency is greater than K. In this case, it's 3 minus 2. So 3 minus 2 is 1. That means we finally saw a character that's not A, we found a B, and we could replace that B to an A, right? And so in this case, the curl minus max frequency is less than K. So we don't need to do anything to the I pointer. We could keep the substring. Let's update the max length to 3, and let's move on to A. Now, once again, we update the frequency of A. It goes from 2 to 3. We update max frequency to 3 and curl to 4. Once again, we check curl minus max frequency. In this case, it's still 1 because we only have one distinct character that is not A. It's just a B. And since K is equal to 2, we could swap that B for an A. So we keep I where it is and we update the max length to 4. Now we move along. We're going to process another B. So in this case, let's increment that to 2. We're going to update max frequency to 3 and update curl to 5. Now we're going to check. What's my curl minus max frequency? Well, it's 2. Is 2 greater than 2? No, it's not. So we could keep this current substring. Remember that 5 minus 3 is 2. It means we have 2 distinct characters that are not equal to our most frequent character, which is A, because we have 3 A's. B. Since K is equal to 2, we could take both those B's and convert them into 2 A's, right? So we could keep this current substring. This is a valid substring for us. Now we update the max length to 5. In this case, AB. If we replace 2 B's with 2 A's, we have A. Now we go on to the next B. Now the frequency of B is 3. And now this is where it's interesting. You could either choose to replace 3 A's or 3 B's. And in this case, the max frequency stays 3, right? Max frequency doesn't care about the letter A per se. It just cares about the most popular letter. In this case, they're equal. So we update max frequency to 3. It just stays the same. And we update the curl to 6. And now this is where things get interesting. Curl minus max frequency is 3. Is 3 greater than K, which is 2 in this case? Yes. And now do you understand this check? Curl minus max frequency is 3. It means we need to swap out 3 characters. But we could only swap out K characters, which is 2. And in this case, we need to swap out more characters than we're allowed to. And so our condition becomes true in this case, which means we need to move the I pointer. And so we're going to move I 1 element ahead. So we need to shrink the window. This is why it's called the sliding window technique. We decrement the frequency of A because we're going to get rid of it now. And we move the I pointer to the next element. And in this case, we satisfy the constraint again because curl is going to become 5 and the max frequency is 3. And now we satisfy the constraint where 5 minus 3 is not greater than K. Right? So now this substring is valid. Now we update the max length, but it's already 5, so nothing changes. And we move J along. Now we increment the frequency of A again to 3. We run into the same issue as before. We update max frequency to 3 and curl to 6. And we're going to be greater than K now, right? It's the same exact problem, except now we added an A instead of a B. So we shrink the window. Let's decrement the frequency of A. So it goes back to 2. We move the I pointer. And now we're less than K. Curl minus max frequency is less than K, so we're good. We update the max length. It stays 5. And we finish our algorithm. The length of the longest substring is 5. It's BA or any other substring of length 5. And this algorithm runs in O of n time and O of 1 space. We only iterate through the entire array once. We just keep track of a sliding window between I and j. And for O of 1 space, we only store a frequency hash map. Now, the reason why this is O of 1 is because the problem explicitly states that we only deal with uppercase English letters. And so the maximum keys I can have in my hash map is 26, and that's why it is constant space. So let's start initializing our variables. We're going to have a frequency hash map, which is just a default dictionary of integers. The default dictionary in Python just means if there's no key in there, it's just going to default the value to 0. So it's just a shorthand notation. Result is equal to 0. This is going to be the maximum length of the substring, and we need to initialize I to 0 as well. Now I'm going to start the for loop with the j pointer. So for j in range len of s, And I want to know the letter at j, right? So let's just say letter j is equal to s of j. And what we need to do is keep track of the frequency of this specific letter, right? So frequency at letter j plus equal 1. Now what we need to do is check the maximum frequency for a specific letter, right? So the maximum frequency for a specific letter is max of frequencies dot values. The dot values will give you a list of all the values associated with that hash map. And so that's really what we're interested in. And we need to calculate the current length. The current length is equal to j minus I. So let me just write that like this, j minus I plus 1. And we're going to check if the cur-len if the cur-len minus max frequency is greater than k, then we need to move the I pointer and satisfy the constraint, right? So frequencies at s of I minus equal 1. So we decrement the frequency count at the letter s. And then we also move the I pointer, so I plus equal to 1. And we need to update the current length as well. So j minus I plus 1. And now we say that the result is equal to the max between the previous result, or the previous longest substring, and the cur-len. And in this case, that's j minus I plus 1, or just cur-len. Now we return res, and that's the algorithm. Let's run this just to verify that it runs successfully. And we're done. Thank you so much for watching. If you're interested in more LeetCode animated style videos, be sure to subscribe and like this video down below. It means a lot to me, and I'll see you in the next one.